All right, this is an example of a three-dimensional question, which makes...
Excuse me?
So we've got a communication tower 35 meters tall. There's a person that's due north of that tower, measuring an angle of elevation to the top of the tower is 70, and then somebody else at a bearing of 175 degrees from the tower and has a different angle of elevation. So the hardest thing in this one is drawing a diagram, because you can't just draw it in 2 dimensions. So how do we draw 3-dimensional pictures? And then from that, make 2-dimensional pictures. So basically, what you have, I'll show you. You won't be able to see this on the video, but here's the tower, right? You have one person. Here we go. These things come in handy. Here we go. We got one person here, due north of the tower. Does that look like due north according to you guys?
Excuse me?
Hello?
Hiroki, Yamashita, and Genta Kawai.
Yeah, they can come down too.
Thank you.
I don't know if this alien ever had a parachute or not, but there he is, due north. I found him in the hallway. These are all toys I found in the hallway. No, it's very, very... And then here we go. We've got another guy at a bearing. Now, bearing starts at north and goes 135 degrees. They would be over there. Yeah, in the hallways of this school, I found these toys, and I have a little collection of toys that I find in the hallway. Yeah, I can show you that. So this is what we have. This little alien is looking at the top of the tower at an angle of 70 degrees, and this alien, whose name is Brenda, is looking at an angle of 50 degrees to the top of the tower. So how do we draw this situation? Can you see that there's a right-angled triangle here? There's a right-angled triangle here. And we want to find the distance between those 2 aliens, Brenda and David. Okay? Now, how are we going to draw that? And when we do draw it, there will also be a triangle on the ground with this length, and the length between them. And that's what we're going to want to find. So here we have a way to draw this. Okay? We're going to draw this in 3 dimensions. Generally, what we do with 3-dimensional drawings is we take a piece of paper. Let's say I have north, south, east, west. And we imagine that paper being laid down on a piece, like on a table, so it's kind of like that. It's not perfectly 90 degrees in this picture, but can you imagine these being 90 degrees just in a 3-dimensional picture? Yeah. So the question is, why doesn't it just stay on the ground? That's a good question. If it was just on the ground with north, south, east, west, right? We know that we had one alien here. That's my silver one. There we go, so the video makes sense. And the other alien at a bearing of 175 degrees, which is almost due south. This guy should be further this way. Right? And we have this length to this one. The tower is right here in the middle. This length to this one. And we want to find out this red line from here to here. Correct? And we know that this angle in there is 175 degrees. Do we know how far David, the gray alien, is from the tower? No. Do we know how far Brenda, the green alien, is from the tower? No. So as soon as we do know those things, then we can transfer them to this diagram and solve it as a 2-dimensional question. I'm just going to show you how you would draw that in 3 dimensions and then go from there. So first of all, we have to draw our tower. So right here, that's a pretty looking tower. There's our tower. So in a three-dimensional picture, we lay down a piece of paper and then imagine something coming straight up from there. We've got David right here, and we know that the angle to the top of the tower for David is 70 degrees. The angle of elevation there is 70 degrees. I'll draw David's triangle in black. We've got Brenda, who's down here. She's another distance away. It makes another triangle, and we know that this angle of elevation for Brenda is 50 degrees. And we want to find out, we also know for Brenda that this big angle in here along the ground is 175 degrees. And we want to find out how far Brenda and David are apart. So there's my three-dimensional picture. And from that three-dimensional picture, I'm going to draw three two-dimensional pictures. I'm going to draw the triangle that David makes with the tower. I'll do that one in black. What kind of triangle? Here's the tower, which we know is how tall?
What is 175 degrees?
175 is the bearing. So from north, south, east, west, a bearing starts at north at 0. 90, 175 would be down there.
So it's that angle over there?
Hmm? Well, this, the green, the black, and the red line in this two-dimensional one make a triangle with an obtuse angle of 175. These other ones will be very small angles as a result. So there's the tower. We know that David was here. We know that his angle of elevation is 50 degrees. We know the height of the tower is 35. And as long as we're not at the Leaning Tower of Pisa, we can make an assumption that this is 90 degrees. His is 70, thank you. That's one triangle we can draw. That's the black one. We also can draw the green triangle. Again, there's the tower. We've got Brenda. Her angle of elevation is 50, right? And the tower is still 35 meters tall, and it's still at a 90 degree. We assume that it is straight up and down. And then we have the north, south, east, west top view as well. Can you see that both of these ones are side views? And this one here is the top view. And they make three different triangles. And here we have the three-dimensional picture showing the whole thing as well. So now that we've got everything there, we look at things and say, this is the one we want to solve for. We want to solve for this length x. But when I look at that triangle, can I use sine law, cosine law, SOHCAHTOA, or a squared plus b squared equals c squared? No, I don't have three pieces of information with at least one side. I don't have any sides. All I have is the angle of 175 degrees. So then I look at my other triangles. Do I have enough information in those other triangles to use something? Yes. And what could I use? I can use SOHCAHTOA. We want to find, we could solve the entire triangle, but there's going to be important information from this. What is the important thing we want to find in the black triangle? The side down here. So I'm going to call that, since I've got x over there, I'm going to call it, I know that you're supposed to label little d opposite of big D, but just because it goes with David, I'm going to label that side as little d, because we knew the opposite was 35. I'm going to label, same thing over here, we're going to need to find that base as well. Can you see that they transfer to the diagram we have in blue? And then we'll have two sides on that diagram. So quickly, SOHCAHTOA you would use tan. Tan of 70 would be opposite over adjacent. How good are you at these fractions that you can do this right away? Are you good at that yet, or do you do two steps? Where you multiply, first you multiply both sides by d, and then you divide both sides by tan 70. Or if you get good at these fraction ones, you can see that the tan 70 and the d just switch places. Type that into your calculator. 12.7 is d. Again, because we're going to be using these values later and I don't want to round early, I am going to tan 70. Once I get my answer, I'm going to store it alpha d so that I have that for later. On my other triangle, my green triangle, I have tan 50 is 35 over b. So b will be 35 over tan 50. I'll go to my calculator. 35 divided by tan 50. Store that one as b. So now I've got both of my values stored. That'll be helpful for later.
Should we just put 29.4 for now?
Yeah. Well, it was 29.3 something. I'm just going to do this to show that I'm not rounding early. Now, when I go back to my two-dimensional diagram here, which I'm going to redraw that triangle right here a little bit bigger just so we have room for things. We know that this is 175 degrees. We know we want to solve for this red side x that'll figure out how far apart they are. We know that David is up here, and we figured out that David is now 12.7 away.
Just a reminder for all the students that are volunteering for the seniors Christmas dinner, if you can please make your way to the cafeteria for your 11:40 meeting. Thank you.
And Brenda's down there for 29.3. Now we have three pieces of information in that triangle. Sine law, cosine law, or SOHCAHTOA? It'll be the cosine law. Yep. So, and we're solving for a side. X squared will be 12 squared plus 29.3 squared minus 2, 12.7, 29.3 cos of 175 degrees. I can go back. So now I just took that triangle, that's the three-dimensional, the top view with the north, south, east, and west, because that's where Brenda is, that's where David is. We want to find out what x is. We can type this all into our calculator. The nice thing is that we stored b and d in, so we can just go b squared plus d squared minus 2 times b times d cos 175. I stored the 17 and the 29.3. Above the on button is a store button. So once you've got an answer that you want to keep, hit that store button, and then I just chose alpha to choose what letter. You have a whole bunch of letters to store things. Usually I just store things as x, but when I have more than one thing, I store them as letters. Once I have this whole thing in, 175, I push enter. That's what x squared is equal to. So x squared was 1770. Square root, that answer, 42. Does it ask for the nearest meter? Or kilometer? Is it kilometers? Or is it meters? No, they're meters. So they're approximately 42 meters apart. So the questions you can do for this one are 9 and 12.